Hi everyone, we're Team PathFinder. We're all SDM students. I'm Suchi.
Hi, I'm Keju.
Hi, I'm Umesh. We were inspired to work on this project when one of our team members, KG, who is an international student, talked about his experience while exploring Boston for the first time. He described his experience of traveling from Chinatown to MIT campus as an unpleasant sequence of events. The existing mapping solutions that are optimized to provide the shortest route fail to highlight risks associated with the route and provide safer alternatives. This experience resonates not only with international students community, but also many of us who travel to unfamiliar cities for the first time. During our investigation, we also learned about crime rate in Boston area. It has been reported that Boston crime incidence is twice that of national average. So we set out on a mission to find a way to help people navigate safely to their destination. We developed a new mapping solution that accepts users' risk tolerance level and provide a safer route while providing real-time crime events.
I'd like to demonstrate our system. The input data of this system are from address to address, departure time, and risk level, which I want to avoid. Let me search the safer route from Boston Common to Fenway Park. So the from address is Boston Common, and the to address is Fenway Park. And the departure time is set to 3 p.m. so 15, and I want to avoid the high-risk area. The red line shows the shortest route, and the pink squares show the highest risk areas, depending on the statistical crime data, and the red line crosses these areas. And on the other hand, the blue line shows the safer route, avoiding these high-risk areas. This panel show the direction of the safer route with total distance and the travel time. Let me change the departure time to 9 p.m. so 21. So in this situation, risk areas change and the safer route also changes. At 11 p.m. so 23. So this is the safer route. Next, let me explain this Twitter information. This shows the real-time information from Twitter accounts, Boston Police, Violence in Boston, and Crime Hub. At this moment, we couldn't integrate this Twitter information with our pathfinding algorithm, but I would like to show what we would like to do in the future. Let us consider a dangerous crime occurs at a Prudential Center. Once the information of this crime is tweeted, our system will identify the location of the crime with this bubble, and find an avoidance path, this one. A real-time crime data must have wider area to be avoided, this one. And our system will set this risk area by this Twitter information.
This slide highlights the underlying architecture and technologies used for the PathFinder application. The user interface was developed using HTML5, CSS, JavaScript, Here Maps UI widget that shows the map and direction, and Twitter widget that shows the real-time curated Twitter feeds. The backend is comprised of Node.js server, SQL Server database, logic for calling APIs from Here Maps and Google Maps. These components are Dockerized and hosted on Amazon Web Services. The crime data from agencies is pre-processed before uploading it to the database. The location extraction functionality, which was our stretch goal for the project, is enabled by Google Cloud Natural Language and Twitter Service APIs. Now I will go a bit deeper into the workings of the PathFinder application. As seen in the demo, 4 input parameters from the UI passed to the backend server. Using the geocoding services from Google, latitude and longitude from and to addresses are requested. The latitude and longitude of the addresses are then used to determine the shortest path using here map routing API. Then the system executes the safe path algorithm to avoid the potential unsafe area. Based on the risk tolerance level selected by users, crime data is extracted from the database using SQL query. This information is then used in the algorithm to find the alternate path, which is then displayed on the UI. The second part of the workings of the application was our stretch goal. In this part, we integrated the application with Twitter to get the real-time data feed. There are 2 ways in which the real-time Twitter data feed is used in the application. First, a curated data feed is displayed directly on the Twitter widget on the UI. Second, the tweeted feed data is used to extract the location information using Google Cloud Natural Language API, which is then used in the safe path algorithm to avoid these areas and update the here maps on the UI as we have shown in the demo. Quickly, I would like to cover our development and deployment tools and processes. We have used GitHub repository for our code. The components were Dockerized and pushed to Docker Hub. Then we pulled the Docker image and hosted on AWS for everyone to navigate safely to their destination.
There is a high potential for extending our application to other opportunities. Our current model handles safe routes within Boston area, and this can be extended to other cities and states. Twitter feed has been integrated with our application. This data can be used to provide real-time information to the users and also help users to navigate away from crime areas. We also plan to extend our platform for listing real-time events for the search area and based on user interests, navigate users to chosen events by avoiding high-risk areas. This is for future enhancements, but what we have now is a base model that can be used by people in Boston to safely navigate to their destinations.